Hello everyone, I'm glad to have this time to talk about Sencha and share some tips on building web applications using Ext JS. I'm Joshua, I've been programming with JavaScript and I have created multiple applications using Ext JS for more than 16 years. I enjoy designing object-oriented software to make the most of code reusability, and this can be done very well in any ExtJS application you might be working on. ExtJS is a library with a collection of components organized in an architecture that, over the past decade, has been hard to imitate. This is the reason why it remains a solid choice when it comes to selecting a tool to build your enterprise web application. ExtJS is a developer-oriented framework. It's action-oriented. Unlike many other frameworks where you also have to worry about creating the styles and designs, in ExtJS components and sites already exist. So this saves time. The goal is to dedicate as much time as possible to creating functionality and business logic, instead of investment effort in designing how the thing should look and what size to display. As a programmer, you don't need to place too much importance on learning HTML or CSS because its philosophy is JavaScript first. In the long run, this saves a lot of time because unifies all the complexity of building a web applications into a single language. The language that the internet browsers natively speak, JavaScript. And if JavaScript is the only thing we need to learn to develop, then let's see how we can strengthen a language that, throughout its history, has been very flexible. Nowadays, there are many strategies, methodologies, and recommendations on how to organize JavaScript. Because, in essence, that's the challenge. Organize it so that it's easy to build, but above all, easy and inexpensive to maintain in the future. And ExtJS does it very well. So let's talk about how we can optimize our Sencha ExtJS application to achieve better performance. The following are my programming recommendations that I have been able to experiment with and applied in the ExtJS applications I've built over all these years. For this, I've organized some interesting topics along with examples to give you the best recommendations you should consider when building an application with ExtJS. As a developers, we know that code efficiency and structure are key to build applications that not only work well today, but can also grow and adapt over the time. In the case of Sencha ExtJS, the source code is where we can truly make a big difference. Optimizing code doesn't just mean making it faster but also clearer and more reusable. This involves practice like organizing our classes and files well, minimizing component complexity, and leveraging modularization to break the application to smaller, manageable pieces. The idea is to avoid unnecessary code accumulation and redundancy in logic, so that the application is easy to maintain and improve. The first thing we'll look at is the organization of folders and files and how these relate to the name of their class and package. When naming classes, naming should be in lowercase, and at the end, the class name should use camel case notation with the first letter capitalized. The namespace is equivalent to the physical path where the file is located, making it easy to find. I recommend using at least 2 words for class names to identify their type and function. For example, panel users, form registered customer, stored invoices. As the project grows, these names will help us to locate the proposed location of each files and class more quickly and effectively. A large ExtJS project should use package independent of the main project to separate groups of classes into specialized folders. This allows us to share code between projects in the future. To create this package, we do it from the command line by typing sencha generate package crm. It only takes Sencha command seconds, and it will create a folder structure within a folder called packages in the main directory. Now let's create a second package. Sencha generate package ERP. With this, we can see that these two structures have been added to our project, allowing us to organize classes related to client management in our project with the package folder. Inside the source folder, we can create an unlimited number of subfolders to organize all the screens we need related to this package. The source folder within the package is where we'll create the JavaScript classes, and this should contain a reasonable number of files to avoid becoming difficult to manage. Instead of having a single directory with many declared classes, it's better to have each folder with no more than 4, 5, 6 or 10 files. In this example, a bad practice would be to declare all the classes of your project at the same level. By comparison, if we structure them in folders based on their context, we'll have better organization for finding and maintaining them in the future. Now, let's open an example code to identify some other suggestions. The first thing to note is that they should always be classes, with a single line of code invoking the class definition, the class name, and structure. A class should not exceed 1000 lines of code. If it does, we should look for ways to divide it with other classes, linking them as a parent-child through inheritance, or perhaps by dividing complexity with a view controllers or model controllers. ExtJS handles this very well. For example, this class here is a file of 700 lines, which is a bit large, so it might be worth analyzing how it could be divided into at least two parts. In the header, we should declare our class's variables, followed by lifecycle and initialization methods like init component, onRender, after render, and onDestroyed. At the bottom of the file, we place the utility methods. If the class is very large and complex, we can divide it into other internal components. The idea is to structure it for increasing complexity over time. Dividing code is a good practice and tool for delegating large responsibilities into smaller pieces of software. ExtJS is a tool that allows you to create large, complex structures as needed. It's highly recommended to follow these practices from the start of a project. Not only will keep you the code clean and easy to maintain, but you'll also facilitate team collaboration and the scalability of your application in the long term. If we use packages throughout our development, we can take advantage of dividing the application into sections that aren't immediately downloaded but instead loaded on demand. Dynamic package loading is an advanced strategy to optimize the performance of Sencha ExtJS applications, especially in large and complex projects. These practices allow only the necessary resources to load when the user requires them, rather than loading the entire application from the start, which can significantly improve initially load speed and application efficiency. Loading on demand means that packages or modules are loaded into browser only when they are needed. If the user accesses that section, then the code is downloaded. This reduces the initial load and allows the application to be faster and more responsive from the very start. We have a basic application that loads all the code at once. Although this works well for small applications, as the application grows, it can become problematic. The example consists of a top panel container with two panels displayed on the screen. If we look at the source code, we can see that these two segments are directly written and are part of the immediate definition, panel 1 and panel 2. What we'll do is use the definition of our CRM package, contain it in the package folder, and locate it locally. Here, I show the contents and the separation of the second panel into an individual class. It's a panel invoices class that inherits from panel and is referenced by its X type name panel invoices. This is just an example. The content is only text. If we return to the main file, we should remove this second panel to replace it with some dynamic behavior based on the user. This could be a toolbar with a button. When the button is pressed, we'll check if the CRM package has already been downloaded. If not, we'll download it via the package loader. Immediately after downloading, we'll add the additional panel to the tab panel and has a final step activated. That should be enough. A very important note, in the app.json configuration file, in the requires definition, you must reference the use of the package loader, and we reference dynamic dependencies using uses in this case, CRM package. To compile our project and generate an output of our package, we type in the command line Sencha app build -uses development. This will scan our project to generate an output version and its dependencies. It's just a matter of waiting a few seconds. It shouldn't take long. Now, let's go back to the browser to test. On the right side, in the JavaScript console, if I try to reference the CRM class invoices, panel invoices, it will show an error because it wasn't defined initially. Let's now inspect the network. We press the button and see how the package is downloaded immediately, and once downloaded, it adds and activates into the tab panel. Perfect! This is a great demonstration that our projects can be enormous, but this tool of separating classes into package and downloading them and demand will make our applications fast from the start, optimizing the performance of large and complex Sencha JS applications. By loading only what's necessary, we can reduce the initial load time and improve the user experience. Let's look at another important point, the efficient use of containers and layouts in Sencha JS. This is a crucial topic for optimizing the performance and maintainability of applications. Containers and layouts are fundamental for creating the user interface. But if they aren't used correctly, they can lead to unnecessary overload in the application, directly impacting performance and the simplicity of the code. Containers are components responsible for grouping other components, while layouts are responsible for organizing and sizing those components within a container. A common mistake is excessive nesting of layouts, where multiple layers of unnecessary containers are created. This not only increases code complexity but also slows down the application's rendering. Another mistake is adding containers where they aren't necessary. For example, a panel is a type of container, so it is not necessary to grab it in another container if it already serves the purpose of grouping components. We should use some strategies for efficient use to keep the structure as simple as possible. Evaluate whether a new container is really necessary or if you can achieve the same design with fewer layers. Select the most appropriate layout for each container. For example, if components need to be organized in a row, an anchor layout might be more efficient than VBox container with a single nested item. But let's look at the sample using a form. The following code represents some nested containers. We see a form with unnecessary levels of grouping and nesting that complicate both the structure and maintainers of the code. In level 1, we start with a main container that uses a VBox layout for vertical arrangement of the elements. However, this container is unnecessary as the viewport can directly manage layout. Here, complexity is added without providing any additional value. For level 2, inside the first container, we see a second container that uses an anchor layout. Although there's only a text field inside this container, another layer of grouping is added without need. The text field could be placed directly into the layout without an intermediate container. At level 3, there's a third container with an hbox layout that groups a single date field. Again, this level of nesting isn't necessary, as there is only a date field, which could be added without this extra container. Finally, in the level 4, we have another container that uses another hbox to group two buttons, Save and Cancel. These buttons could be placed directly within the upper layout without needing this grouping. In summary, this code contains containers and layouts that do not add any real functionality and only increase the complexity of the code. This can slow down rendering and make the application harder to maintain as it grows. Let's compare this code with an optimized version. We will eliminate unnecessary nesting and simplify the structure to make it more efficient. The first removal is the container that grouped a single text field, or the one that only contains the buttons. Now, the components, text field, date field, and the buttons are added directly within the main layout. We've kept a simple bbox layout, suitable for arranging elements vertically. This makes the code layout and understanding easier. A container is only used when truly necessary to organize the buttons currently in a single space. With these changes, the code is now cleaner, more readable, and easier to maintain, which also improves the application performance. Instead of multiple levels of nesting, we've simplified the structure, allowing elements to render faster and more efficiently. In Sencha Ext JS, less is more when it comes to containers and layouts. A simpler and more direct code structure is not only easier to maintain, but also provides better performance and better user experience. Let's talk about another fundamental aspect of successfully creating applications with ExtJS, the creation of independent components. This strategy is a key practice in developing scalable and maintainable applications. It involves designing components as independent models, like pieces of a puzzle with a complete independence, each with its own behavior and style, to make it easier to include them in different views or projects. Additionally, inheritance-based coding allows for code and functionality reuse, which is essential for maintaining consistency and reducing code duplication. In large and complex applications, creating independent components and classes is crucial for keeping the project structure clean and easy to scale. By breaking the application down into individual modules, we can manage different parts of the application in isolation, making maintenance and evolution easier. Module division involves creating components that function independently and can be reused in the different parts of the application or even in other projects. In Sencha Ext JS, inheritance allows us to create basic components that can be extended by other components, sharing common functionality and styles. This reduces code duplication and facilitates updates. Let's imagine we're developing a user form that includes basic information like name, email, and phone number. This form could be part of several sections of the application, such as registration, profile, or user management. This code might look like the following example. The form has a title, is rendered in the body of the screen, has a width of 400 pixels, and includes three fields: name, email, and phone number. At the end of the form, there are two buttons, Save and Cancel. This code represents the creation of a form panel directly. and we configured its content for this component. Although this code works, it's very specific to a single use case, a one-off single use. If we need a similar form somewhere else, we'd have to copy and paste the code. Copy and paste, which is not ideal for maintainability. And this is also terrible for long-term maintenance. Let's separate this form by creating an independent component that can be reused in a different parts of the application. What we'll do is create a user form class, which will act as a factory to create fully independent components. Unlike the first example, where we directly create the form, in this case, we'll handle from the form panel to define a user form class and then configure it. The content is the same as in the first example. We can reuse this new code in any part of the applications simply by adding Ext type user form. To demonstrate how this component is reused, we'll add it to a different views of the application. Here, we can create a window and then include the user form within the Windows content. Let's imagine that we have another section that will be a panel, and in the body of the panel, we can also define the user form as content. As you can see, we're using the same user form component in a profile editing window and in a user management panel, which saves us a lot of code and ensures consistency. But let's look at another advantage of structuring of components this way. Let's separate this component into an abstract, reusable logic, and extend it so we can let it reuse most of the functionality in a second form, a client form. The body of the abstract form should only include general configurations that can be reused in another form, or at least in most of the future forms that need to be built. For example, almost all forms have a save button and cancel button. So these are the visual elements that will be included in a generic form. If we extend from our form, we'll be reusing all of its configurations and behaviors, so we don't have to rewrite them. This structure will allow us to extend and create a user form, then a client form, perhaps an invoice form, and any other. All the forms in our application shouldn't extend from this single form, which will control the most repetitive behaviors for each of them. In the case of the user form, it will no longer be necessary to rewrite the button definitions. We'll only need to declare the elements in the body, such as the fields for name, email, and password. In a second child form, a client form, it extends from the base form and rewrites its own set of fields, which are entirely different from the fields in the user form. In a conclusion, we can implement a lot of shared functionality that may be complex, but by writing it once in the parent class and then extending it into the child forms, we avoid ever having to rewrite them, keeping the code dry. Don't repeat yourself. Dividing code into independent classes and components based on inheritance are powerful tools for designing scalable and maintainable applications. By breaking down your application into reusable modules and extending components when necessary, you can significantly reduce code duplications and make long-term maintenance easier. But don't limit this idea to just a base form. Let's take it further by creating a library of reusable components that can be shared across different projects and teams. This practice not only speeds up development but also ensures consistency in the user interface, which is crucial in large collaborative projects. In this segment, we're going to explore how to create a structured and shared component libraries so the other developers in your team can use them in different projects. We'll also look at the practical examples of common components beyond forms, grids, windows, and how to predefine elements like combos to speed up development and improve maintainability. But first, what's a shared component library? A component library is a collection of predefined components that encapsulate reusable functionalities. In ExtJS, you can create an internal library for your team where you store reusable components with pre-built functionalities. The main benefit of this is that you speed up development, as you don't need to recreate these components from the scratch in each new project. You maintain visual and functional consistency across different projects, ensuring a cohesive user experience. You make maintenance easier, as any change or improvement in the base components can be applied to multiple projects simultaneously. Great, let's get started. What are the key components we should include in our library? First, let's consider generic and abstract components that serve as a base class to be reused. For example, store base, a store that predefines the proxy configurations and response reading for data groups. It only requires defining the URL where the data will be read from. Grid panel base, a grid panel that builds pre-made row controls such as deleting, viewing details, editing record, and managing row selection. Form panel base, our example from our earlier will actually become a piece of our pre-built class library. Window base, a window with visual elements that are consistently repeated through our application. We should also include specific, ready-to-use components that already contain pre-made behaviors. For example, combo months predefines the 12 months of the year. Combo yes, no, a boolean combo with two values, yes and no, which can later be changed to active, inactive, or accept, reject. It actually has many applications. Combo gender, male and female, which actually extends from combo yes, no. Combo currency, defines are stored with remote data and is populated with available currencies that can be selected by the user according to specific configurations with which it is instantiated. It's a generic combo but with a high potential for reuse. We'll define this and any other components and classes we create in a base package that's independent of the application, with indentation that it can be reused in a second project. So let's create our package. Sencha generate package base. Let's take the grid panel as an example. In ExtJS, grids are a fundamental tool for displaying large amounts of data in a tabular format. Creating a base grid with a common configurations can save development time in the long term. But what are the repeated features of a grid and a store that needed to be unified into a base entity? Let's consider the definition of a grid panel base that sets generic, reusable behaviors that can be repeated through the inheritance in any other grid that extends from this base class. If we can do this, we could then define grid sales, grid invoices, and grid users with minimal effort because all the complexity should be managed within the base grid panel definition. Let's look at the following code. Here we create a basic grid that has pre-made methods so that the child components don't have to repeat them. To access these methods more quickly and easily, we'll use configurations, which are the children's definition of how they want the parent to behave. This grid can be reused in multiple projects. Our grid panel base extends from Ext grid panel. It all begins on line 10, where the init component method is the initializer for all components. Only components, I repeat, stores, view controllers, and models don't have the init component method. Here, two constructor methods are invoked. The first is for the store, predefined with the body of the same class. It will invoke a store based in the URL preconfigured by the child class. The second method is empty, has a column art specific, and must be provided by his child. In this way, we'll create an extend example, grid invoices, which is an independent class and file. What we're aiming for is to reuse all the possible generic behavior contained in the parent class, making programming over time as easy, fast, and concise as possible. The philosophy is that, over time, building should be cheaper, not more expensive because it becomes more complex. Grid invoices extends from grid panel base and, in this example, only needs to do two things: define the service from which the data will be read and define a function that generates the columns. The columns aren't defined as a configurations, but within a method, and this is because in real-life applications, columns can be very complex. They need to be tied to a context, invoke other functions, read properties, and set conditions. Therefore, it's more appropriate to handle all this work from a function. The bulk of the work we need to do at the beginning is the construction of the parent class. In the future, defining child classes will be faster and easier. Let's now make an example of specific components with predefined data. In this case, we'll define two combos: combo yes no and combo gender. We'll start by creating the general structure of a ExtJS class using the define method. Defining combo yes no. It's important to note that this combo extends from the structure of the combo box field, the component that already exists in the ExtJS library. The alias of our component will be unique, and it's the same name as the class, combo yes no. It doesn't use remote data. The data is local. The field used to define the value is value, but the value that should display it on the screen is label. Label 0 and label 1 will be yes and no, respectively, and the values the form should submit will be 1 and 0. With this, it's sufficient. This class will later become our base class for creating the combo gender. From that point on, it will be much easier to create child classes that extends from the combo yes no. So in this way, we'll reduce most of the code, only rewriting two fields, label 1 and label 0 to their values, male and female. Regarding its use, we can create a form containing these two fields by creating them through the X-type configuration, combo yes no and combo gender. Their equivalent appearances on the screen is, as we see here, two input fields that are combos. For this example, we use the field enable. Its selectable values are yes and no. And of course, for the gender combo, the values are male and female. Having a predefined combo like combo gender, combo yes no, or combo months, combo countries, combo currencies avoids the code duplication and ensures consistency in how those options are represented through the application. In summary, if we can create a library of predefined, reusable components on top of the ExtJS library as our own library, we'll save time and money in the future. The benefits of the shared component library are vast. Efficiency. We can create complex components once and reuse them in multiple projects. Consistency. User interfaces are coherent across the application or between different projects. Easy maintenance. Updating a component in the library automatically impacts all places where it's used, making updates and long-term maintenance easier. This in-house library is a key strategy to increase the development team's productivity, improve interface consistency, and reduce development time. Basic components like grids, forms, modal windows, and predefined combos are ideal starting points for building a reusable collection that can evolve with your project and adapt to the new requirements. And predefined combos are ideal starting points for building a reusable collections that can evolve with your projects and adapt to the new requirements. Let's now talk about simplification and minification of resources. This topic is very important because JavaScript applications must generate optimal source code to deploy it to your final server, where it will function as the production version of the application. We're talking about one of the final and most critical steps in developing applications with Sencha ExtJS. Minimizing and compressing resources is a crucial practice for optimized web applications performance. During development, the code is often filled with comments, white space, and structured well to facilitate maintenance. and the source code also includes descriptive variable names. However, in production, it's essential for this code to be as compact as possible to reduce load times and improve user experience. In other words, transforming it into a more minified and efficient version. Minification is the process of removing all the unnecessary white space, comments, and characters from the code without changing its functionality. This significantly reduces the size of the JavaScript and CSS files. For example, if we were to combine all the files created and created in your project, together they might weigh about 4 megabytes, but minified, the final result will be around 3 megabytes. On the other hand, compression goes a step further, using algorithms to reduce file size even more. Often, it remains variables and functions with shortened names to reduce file size. For example, renaming variables like win, doc, element to J, B, A. To a developer, the variable A doesn't make much sense, but to the browser, it's all the same. By swapping names, the output files have a lower weight, which is essential because client browsers need to download these files to run the application. From 3 megabytes, the final result might be reduced to 2 megabytes. Sencha command is a powerful tool that not only facilitates the construction of your application, but also includes functions to minify and compress resources. The typical workflow will be to develop the code, test it, and then use Sencha command to create a production build that includes minification and compression of the files. Here we have a typical JavaScript project during the development phase. It's well commented, has a descriptive variable names, and is easy to understand. When we load it in the browser, many files are downloaded, and in total they weigh quite a few bytes. We'll use Sencha command to transform this code into a production version. Sencha app build. This command will generate a minified and compressed version of our application. Sencha command automatically removes comments and reduces the size of the JavaScript and CSS files. We can see the difference in a file size and code structure before and after minification. The entire project is summarized in the app.js file, and if we open the content, we'll see the following code. It's more compact, meaning it will load faster in the user browser. This is an essential step to ensure that your application is fast and efficient in a production by using Sencha command. Upon reopening this project, the application only downloads a few JavaScript files, and the total weight is much lower. By having smaller, more compact files, the application loads faster, which is crucial for improving user experience, especially in a slow connection or mobile devices. For now, that's all, folks. I hope the examples and demonstrations we had in this time together have been illustrative and that you can take away some ideas to apply in your own Sencha ExtJS projects. If you need my help, here's my contact information so you can reach out. Wishing you all the best on your development journey. Thanks.
All right. Thank you, Joshua, for a fantastic presentation. For those who don't know me, my name is Wermerson Januario, and I am developer advocate at Sencha. I will be moderating today's webinar and facilitating the question and answer session. We will now transition to our question and answer session. If you have any questions, please type them into the question box, and we will address as many as we can. All right.
Hello, Emerson. How are you today?
I'm doing well. Thank you for joining our fantastic presentation, Joshua. So here we have one first question. And the first question is, how can we ensure that code in the Ext JS project is scalable and easy to maintain in long term?
Well, I think that success depends mainly on how we can organize our code from the beginning. So, and this point is important. From the beginning, So although there is no a single way or a single precise way to how to do things, and um, maybe maybe we can have a list of good practices that are highly recommended to take into the action. So some good practice maybe include um, and this is a sentence that I like: divide and conquer. No? So it is important to divide applications into smaller pieces, modules, packages that can take care of a specific tasks. So also this is important to reuse as much as possible through inheritance and create reusable components, and this way we can extend from other specific components too. So we can reduce the code duplications. So so in this, it is important to use classes, and also the namespace pattern is important. I would say that also don't write very large classes, write comments, so many others. Yes.
All right, thanks. The next question we have here is, what is the difference between a controller and a view controller?
Okay.
In the past, we used, I could see that many usage of controllers on MVC application, and now you can use a lot view controller. Can you explain to everyone how it works and the difference, please?
Yeah. This is a very good question. And it is important to understand what's the difference, because we can use one or another. So a controller is a component that handles a global logic of the application, or maybe a global part of logic of the applications. Also handles the routing, route management, event handling, and some interactions between views and models. So in this way, controllers are not directly tied to a specific views. But in the other hand, view controllers are classes specialized on controlling and handle a particular just one view, or only one view, handling specific events and actions for that view. So the view controller born with the component and dies with the component, and manage the logic and all the code just for one individual component. That's the main difference.
All right, amazing answer for that. Thanks. We have another question here. Let me check it. Okay. If I'm starting with Ext JS, what is the most important topics that should be covered and applied in a web application?
Okay. ExtJS is a library rated in object-oriented programming philosophy. So I would say that it's important to understand, first of all about this object-oriented programming. This is important to understand because the basics of this pattern are classes, definitions, inheritance, reuse code. But once we start, it is important to learn some things that it is important inside the ExtJS, and this is how we can create and configure components, what are containers and the difference between containers and components, what are layouts inside containers. And among the components, there are also some important components like the grid panels. For example, the grid panel is a very important component, and inside the grid panel, you need to learn what's the difference between stores and models, and how we can take advantage of each one. But there are many topics that are important, such as form validations, and also there is a very important like communications between components, event handlings, or maybe as in the future it's important to understand how to do optimize code, or how we can have for better performance, and how we can organize and have responsiveness adaptively, and many others.
All right. I was seeing your sales application inside your presentation, and we have one interesting question here about it. And how do you know when to create a new component or use an existing one? And when is necessary to keep dividing the application into parts, given that we are creating one bigger application? So can you explain this, please?
Yes, this is a question that it is repeated in many presentations. So create a new component. It is important when the functionality doesn't exist yet. So when you need also a unique functionality or behavior that cannot easily be achieved with the existing component, you need to look for inside your companies if there exists. But if they're not, you maybe you can organize the code looking for a future reusability. So use an existing component when it fits in your needs, and when you are looking also efficiency and not to repeat code, so you can reuse that component. And I would say that divide applications into smaller parts when the logic becomes complex or repetitive, when you need to have better performance that justifies create a new component. So that's a good reason. Also, when you need to divide the responsibility between components, in this way, this is also important to divide or create a new component. It is also to understand that when we have a component and you have dealing with a new functionality, but it's a functionality that maybe fits in, it's not exactly the same, but it fits something like the existing ones. Maybe you can extend and only rewrite some of that functions.
Good.
Please go ahead.
Okay, I have one more question here. Okay, so the question is, how can I achieve an efficient responsive design in ExtJS application without overloading the code with additional configuration, given that today we have applications that can run in mobile and desktop device? So how can I achieve an efficient responsive way?
Yes, you're right. You said a very good sentence here, that it's important to notice what is from the beginning. As I said, from the beginning, it's important to take some decisions, and these decisions are fundamental from the beginning, and it is decide which toolkit you are going to use. Because in ExtJS we have more classic, so it depends on what are you doing or what your application is going to do in the future, and what the users are going to use, what device are going to use the applications. So from the beginning, decide which is the appropriate toolkit. Maybe you can working on desktop versions, but mostly the users now are accustomed to use from the cell phones. Therefore, we must keep in mind that it is important to set in. Maybe you can use responsive config, that is a configurations inside the components, or there is another one that is called platform configs. So in this way, we can manipulate and visual behaviors that depends on the dimensions, or maybe from the device, like the operating system. So in order to have a better performance or have to better sizes of components, you need to take care about the toolkit and the size and setting the responsive of these configurations inside the components.
All right. I have another question now with the questions about the grid panel. I could see in your presentation the way you create some base grid panel, and sometimes this is also we may have some question about the way you create your column, you build your column using methods. So the question is, isn't it a bit of overhead, the functions to create the columns, when they can be typed directly into the grid? This is one question from another member in our webinar.
Okay.
Could you understand the question?
Yeah, well, the question is about if we create some columns or many columns, this is overhead function. This is exactly what it means.
Sorry?
Robertson? Yeah, I mean, the question is about if it is, if we create many columns inside a grid panel, this is a overhead, or how, or why? If it is
the question is, for example, isn't it a bit of overhead, the functions that create the columns when they can be typed directed into a grid? For example, I understand the question is, for example, you can also specify the columns property inside the grid panel, and you can also create one build columns method that will generate the columns for you. The question isn't a bit of overhead creating functions to create columns instead of type it directly into the grid panel?
Oh, okay, I understand.
I guess this is the question.
Yes. Well, what I think is that it is important to create functions to create the view columns, because sometimes the columns needs to be tied to the scope of the grid. So in this way, you can use the reservoir word this to achieve the scope. So the columns also have some configurations like renderer, or many others like summaries or something like this. Maybe you can create dynamically operations or dynamically take decisions to build these columns. So most of the times, create columns needs to be tied to that scope. So if you create a functions, that scope is tied to the grid panel. But if your grid panel is a simple grid panel, maybe it is not necessary. But I think it is most of the time, these columns maybe can be complex. So in order to extend this functionality in other childs, maybe you can create a function, and in this way, when you extend, you can rewrite this function to maybe add some columns or maybe remove some of them. So maybe you can create a column called a grid panel customer, and you can extend that to create a grid panel users, but maybe you can reuse 3 or 2 columns. But if you use a function, you can create adding, or maybe you can rewrite entirely that functions, but you can reuse the many other functionalities inside the grid panel. Yes.
All right. I have one other question here about responsive design. Let me check here. The question is, when I use a border layout, I have different parts that I can resize. For example, how to achieve a responsive design on that. I mean, when you resize, for example, the center region, should I react on resize event? Can this be combined into with responsive design? I guess the question is about maybe the answer for that is about using responsive config and something like that. Could you understand the question?
Yes, what I said is that maybe border layout is a layout used in the classic most of the time. And this border layout is not recommended when you need to have responsiveness, because border layout is, from my point of view, is hard to operate. And the regions are not precisely the best way to interact with when the size of the window is responsive. So if you need to have this kind of need to have this responsive, maybe I will say that you need to change from border layout, or maybe you can change from another, like HBox or BBox layout. So so I won't use border layout when you need to operate with the mobile devices. Mm-hmm.
All right, I have one last question here. I guess I can answer this question. The question is, when will this recording will be available, and will it be available on our Sencha YouTube channel? So the answer is yes. We are going to publish on one working day. So stay tuned for that. So do not have any other question here. So as we wrap up, I would like to thank you, Joshua, for the insightful presentation, and now off you for your presentation, participation. We hope you found this session valuable and experience. So thanks everyone for joining for today's webinar. And if you'd like to learn more about Sencha Ext JS or revisit our today's content, please wait for one working day, and we are going to publish this on our Sencha YouTube channel. So thank you once again for joining us for today's webinars on optimizing your current ExtJS application for better performance. We look forward to seeing you on our future webinars. So have a great day for everyone. Thank you.
Thank you. Hi, Emerson. Thanks. Goodbye.
Bye-bye.
Thanks, everybody.